Hi everyone. Welcome to our today's AI seminar event. Um, thanks for everyone's patience. My name is Christina. I'm the marketing member from the CIE Bay Area chapter, and we have our volunteer here from CIE Bay Area as well, Yanshu and Meng, and also our honored speaker, Dr. William Cao. Well, before we get started, um, I would like to give everyone a short introduction and background about the CIE. So CIE represent for Chinese Institute of Engineer, and we are the CIE chapter, Bay Area chapter specifically. So the CIE organization was founded in 1917. We were the nonprofit professional organization of Chinese American engineers, scientists, and other professionals. The objectives for CIE are to promote science, engineering, technology, and mathematics. And also, we try to serve in all the communities across the United States and provide recognition and reputation to all the professionals in all the national level. So long story short, we're the nonprofit organization who are devoted to serving the whole Asian engineers, scientists, and professional community. And also want to give a little bit short history about CIE. Probably a lot of people can recognize the picture at the front. It's a famous Chinese engineer called Zhang Tianyou. So he was the first president for CIE, who was also helping to found this organization. There's probably something. Let me fix. Oops. Okay. Can everyone see my screen right now perfectly? Okay, so sorry about that. Okay, let's continue. Yeah, so probably some of you guys can recognize the picture at the front, which is the famous engineer Zhang Tianyou, who originally founded this organization, including Zhang Tianyou. We have a lot of famous engineers actually from CIE. For instance, Boeing's first aerospace engineer is actually came from CIE, which is really impressive. Next one. Yeah. So currently, we have 6 chapters under the umbrella term CIE. We have Greater New York area, San Francisco Bay Area, which is us, and then Seattle, Dallas, New Mexico, Southern California. And then, yeah, so for us, CIE, San Francisco Bay Area, we were founded 43 years ago, from 1979. And then, yeah, we have been holding a lot of events since then, so which is really impressive. Yeah, so I want to give a little bit introduction about the events as well. So CIE hosts a lot of events, and we have really strong collaboration with many organizations, either locally or across the whole country. We're also very resourceful and supportive, and we truly encourage everyone to actively sign up for all our events and to participate all of the events. For instance, last weekend, our CIE Bay Area committee was invited to one of the private banquet we got the chance to meet Jensen Huang, which is the CIE from NVIDIA. We got the chance to talk to Jensen and have dinner with Jensen. So it's, pretty fun. So that's why one of the reasons for everyone to sign up for our events. You got to know everyone in this area and, to network, to learn more, emerging technologies and all the new topics in this industry. Yeah. And also another highlight is the title here, which is called AAEOY, represent Asian American Engineer of the World of the Year. It's one of our highlighted events at CIE. At this event, it's annual event, and we nominate and give awards to Asian engineers, scientists, and professionals to really appreciate their contributions in this community. Like for the past week, been giving the Nobel awards winner from MIT, which is like Indian American. Yeah, so that's one of the highlights here. Yeah, so yeah, that's all the highlights from our previous events, all the pictures. Yeah. Yeah, see, as you can tell, we have a lot of collaborations with local organizations. Yeah. So under CIE Bay Area chapter, like specific this chapter, we have 5 technical groups. Emerging technology group, electrical engineering, computer science, electronic design technology, biomedical engineering, and young CIE. Yeah. Well, last but not least, remember to sign up for our newsletter and follow up all the social medias so that you can sign up for all the events and never miss any information. And also, we also post a lot of past events and recording on the social media, like for instance, YouTube, and also LinkedIn and Facebook. So it's a great way if you cannot participate in one of our previous events, you can also, always check online. Well, now I'm going to introduce our honor speaker for today's AI seminar, Dr. William Cao. So Dr. William Cao received his BSEE, MSEE, and PhD from University of Illinois Urbana-Champaign. He worked in the semiconductor and electronic design automation industry for more than 30 years, holding several senior and executive engineering management position at Texas Instrument and other companies listed here, and more than 40 technology papers on the IC, CAD, and IEEE journals and other conference. And then he's also adjunct professor at UCLA Electronical Engineering Department. And then senior member of IEEE, and currently teach clean technology and emerging technology courses at the University of California, Santa Cruz, which is really close by. So yeah, probably a lot of students from that university know Dr. William Cao. Yeah. And then has given more than 90 seminars in the past 10 years, well, including today. So yeah, Dr. Cao is a technology watcher, learner, and teacher. Well, now let's welcome our honored speaker for today, Dr. William Cao.
You moved my phone.
Yeah. Oops. Oops.
Are the people online watching this screen?
Oh, that doesn't show. So
Not sharing that.
yeah, drop the phone. No, share this one so that everyone can see.
Okay. All right. So again, welcome everyone to tonight's seminar. there are a lot of people via Zoom. And for the people who are attending tonight's event here, we really appreciate you driving over here. I know that right now the night gets sooner, right? So it's actually pretty dark already. So I appreciate you coming after work and so on. Okay, so tonight's topic is going to be on AI 2023. Okay, so you're going to hear the latest and hopefully the greatest of what's going on. Okay, so right now, everybody knows that what's current, the most current is called the generative AI. Okay, so I'm going to start by talking a little bit about the generative AI, the capabilities, benefits, limitations, applications, and so on. And then I'm going to go and move on to what's coming. Okay, so I don't know where you belong to the camp where you want to know what's happening now, what you can do with ChatGPT and prompt engineering, or you are actually more curious of what's coming after that. Okay, either way, I think you hopefully you enjoyed the talk this evening. This is the agenda for my presentation tonight. I'm going to start by talking about generative AI, talk about the various methods of machine learning, supervised learning, unsupervised, reinforcement learning, some of the capabilities as well as limitations, and all the applications that you can apply generative AI. Then I'm going to talk about some other AI-related topics, like for example, cloud versus edge, model-centric versus data-centric AI. And then the section 3, we're going to talk about maybe some of the things that you may not have been exposed to. Okay, but you'll be walking out of this room more dangerous, right? Because now you hear about all this new stuff. There are approximately 7 or 8 new AI methodologies: Causal AI, Composite AI, Federated AI, First Principles, Neuro-symbolic, Responsible AI, and AI Trust, Risk, and Safety Management. And then I'm going to wrap up by giving a summary and conclusion. Okay. So usually the way I usually give every seminar is I always start from square one. So just in case people are not aware of what it is, we're all going to be on the same page, okay? So we'll start, since the topic for tonight is going to be on AI, I'm just going to start with the definition of what AI is. So AI is the theory and development of computer systems able to perform tasks that normally a human can perform, okay? So intelligence is a trait of a human, it's a characteristic of a person, okay? So artificial AI or artificial intelligence means that how do we make a machine behave and have the properties of that a human can have, okay? So in the box down there, you can see that these are some of the things you can do. For example, we have eyes, we have ears, we have nose, we have all the 5 touches, okay? So all this require for a human to be able to do this, you need to have visual perception, okay? You can be able to articulate voice, speak a language, okay? You also, there's intelligence. That means that whenever you need to make a decision, you also rely on your brain, okay? Rely on your intelligence, right? So all these things are really part of AI, okay? So in order to have a complete AI, you need to be able to do all these functions, okay? So here I've sort of summarized in this slide what is covered by intelligence, okay? So we learn things even when we started as a kid, you learn about how to do new things. So learning is based on intelligence. Also, whenever you want to make a decision, okay, you need to be able to use your logic and reason why you make certain decisions. Whenever we encounter a problem, we need to solve the problem. So problem solving. Okay. Also be able to visually see things. Perception, not only video, but audio as well. So you hear things, you see things. Okay. And of course, we have to communicate with other people. So it requires a language. Whereas the English, Chinese, whatever, you have to be able to go and speak in a language so that other people can understand. So all these are traits of a human, the human can do. And when we're talking about artificial intelligence, in order to meet the criteria is that hopefully artificial intelligence can also perform all the functions that a human can do. And these are the ones, okay? So this chart, like if you have a chart outlining all the components of AI, okay, this one covers that. So again, we start, for instance, the thing about the language, be able to speak and make a speech, okay? You have that, you have vision, you'll be able to see. So computer vision is that have the machine be able to see things, okay? You have natural language, you need to be able to communicate in a language or even translate from one language to another one. The other one is robotics, okay? Robotics is that right now, if you look at ourselves, not only can we okay, great.
Little battery for
okay.
TVs.
Thank you. Okay, so the other thing that we as humans, we have not only the brain, okay? So normally people associate intelligence just with the brain, but in order to fully imitate the person, you also have to be able to walk around, okay? So move around. So you need to have motion, okay? You also need to be able to do something. So we have hands, humans have hands, humans have legs, okay? So in order for a machine to do all those functions, that's where the robotics come in, okay? Robots have arms, they can do certain functions, they can move around, where it's a bipedal using like two legs, or it's like a track, like a wheels, okay? And then you have to learn new things, okay? So we'll be cover some of this, all of these things in detail, but you have vision, which includes image recognition, machine vision, computer vision. You have natural language processing. Is that how you understand the language? Well, you need to know a little bit about the grammar. You need to know about the vocabulary, okay, terminologies. Recently, a lot of focus has been on machine learning. So we'll be covering all the machine learning stuff within 1 hour. So in 1 hour, you'll be able to assimilate a lot of knowledge, okay? That normally, if you were on your own, probably would take you weeks, okay, to read all about it and so on, okay? Okay, so this is the, if you call it like when you are in a company, you have like org chart. So this is like the org chart. This is, everything that is under AI is under on this slide, okay? Okay, so this is another way to represent all the topics that we'll be covering tonight. I don't know where, when you guys went to school, did you already study in high school? Did you study set theory? Called set theory? And you have all these diagrams. Okay, so like in this case, you have the, on the outer edge, you have AI is the whole thing, the whole enchilada, okay, AI. And under AI, you have machine learning, okay? So that's a smaller sphere under AI. And under machine learning, you have a thing called deep learning. So if you are following AI these days, and you read, where is a technical article or read the news, you're going to be running across all these terms. So by the end of today, you'll have all these terms. You'll be described and introduced to all this terminology. So one of the things that we always being exposed recently is called deep learning. Okay. Now, so let's come back to first to machine learning. Machine learning, all of the ones here listed on this right-hand side, like supervised learning, unsupervised learning, reinforcement learning, and deep learning. They're all part of branches of machine learning, okay? And then the talk that we'll be focusing this evening is the generative AI. Generative AI is under deep learning. Okay, so this chart shows you more or less in using set theory and things, the domain. Okay, what is the big circle, what's the medium circle and small circle. But this is what we will be covering this evening. So I'm not going to go over line by line, but all the topics I'll be covering what the main issues of each are. Okay, so we start with supervised learning. Supervised learning is the most common type of learning that the machine use. And what that relies on is that it relies on a human to classify the topic, and it assigns labels. So it fixes labels to everything. Okay, so whenever it's called supervised, it's because it's supervised by a human. The human trains the computer. Okay, so the machine is actually being supervised by a human who inputs the information to the machine. So that's called supervised learning. And in order to do supervision, you need to label everything. So if you see 20 pictures of a cat, okay, you have black cat, you have a brown cat, yellow cat, and all this stuff. Well, each cat has to be labeled, okay? Because otherwise, how does the machine know that it's a cat and it's not a dog, and it's not a horse, okay, or a mule? So the human labels each figure. Okay, that's what is supervised learning. But this type of learning as you can see, has a limitation, because that we live in a world that you're not going to put a thing on the table, say, this is a table. Okay, oh, Tony's wearing a hat, and what he's wearing on his head is called a hat. Well, imagine that we have to go and do everything. You have to label everything. That's going to be very painstaking, right? Pain consuming. So that's not the natural way of things. Mostly when we go around the world, you don't have seen a sticker around everything. Red chair, yellow chair, a table, a PC, an Apple PC. You don't go. So most of the things are unsupervised learning. Unsupervised learning means that there's no labels, okay? And the machine has to learn just by observation. By the way, when we are young, when we are a baby, or when we're in elementary school, that's the way we learn. We learn with unsupervised learning. So whenever the parents are not around, they're not going to say, okay, this is a horse, and by the way, you're going to be riding on a horse, and we're driving there in a car. The way that the kid learns about things is just by watching and learning, but it's unsupervised. Unless you have a parent that say, oh, by the way, you don't know, this is the first time I'm going to take you horse riding. So by the way, this is the first time you're seeing a horse, or this is the first time you're going to be boarding a plane. So what you're being riding on is a plane. Sometimes we do teach, but most of the times the kids just watches the surroundings, and the learning is done without supervision. Okay, so that's the way that most of the world is around us, is in that format, is unsupervised. Okay, then there's a third way called reinforcement learning. So what is reinforcement learning? Okay, this is what they call reward and penalty. Okay, so if you teach a kid and he does a good deed, you say, oh, you did a good thing. I'm going to give you some candy, or I'm going to give you some allowance so you can spend it. If you did something bad, okay, you either get a spanking, or you say, well, you cannot go out with your friends for this weekend. Okay, so there's a penalty, right? So reinforcement learning is a reward and penalty mechanism that whenever they do well, you promote it, and you say, oh, okay, you did a good job. Okay, and whenever they did something bad, you also tell it, okay, well, that's not something that you should do. Okay, so there's a penalty. So, and then by continually doing that, then the kid or we learn what is good and what's bad, right? So if you go and rob something or steal something, you may go to jail and say, well, next time I'm not going to do it again, right? Because that's a penalty, okay? But if you get a award saying, okay, well, you have been attending all the seminars that Bill Gates gives, or you're going to get a certificate, right? So they say, oh, well, next time I'm going to come again, okay? So that's the reward and penalty. So that's the reinforcement learning. Okay, now what is deep learning? So I'm going through all the types of learning so that if you're new to AI, tonight you're going to learn everything about AI, okay? So one term that you read and see very often right now is called deep learning, okay? What is deep learning? Deep learning right now, way back in the starting in 1950s, there are some people that say, we're going to try to make the machine behave like a person. So if that's the case, how does the human intelligence work? Okay, so say, well, how does the brain work? How does the human brain work? And they discovered that inside our brains, there's a thing called neurons. Okay, neurons are just like nodes, and each node you stimulus, you put a stimulus, and that neuron excites the following neurons. Okay, you pass on the information from one layer of neurons to another layer of neurons. Okay, so that knowledge or system was called ANN, artificial neural neurons. Our brain is based on neurons. Okay, so now we're trying the machine to behave like human brain. So this is called ANN, artificial neural neurons. Now, as I said, everything you start with a stimulus. So you have an input, and then at the output, you have an output. But right now, everything that we deal with is very complicated. So you cannot just say, I have an input, I have a processing unit in the middle, and then you have an output. So because of the things, it's so complicated. The word deep learning means that there are many, many layers in between the input and the output. Okay, so it's called deep. Deep means that there's a lot of layers. So that's what deep learning is. All right. Now, there are two types of deep learning. Okay, one is called discriminative. That basically it classifies things. Say, okay, this is a dog and not a cat, or this is a horse and not a crocodile. Okay, that classifies things. That's called discriminative. And the one that right now we'll be focusing right now tonight is called generative AI. Generative AI, what does the word generative mean? It can generate new things. It can create new things, okay? So, yeah, unfortunately, this thing is being blocked on the bottom. But anyway, the generative AI is something that based on some input, it can create data that is similar to the data that you observe. So it's generative. It generates new data. Okay, so that's called generative AI. Okay, so again, using the Venn diagrams. Okay, so we have artificial intelligence. That's the big circle. Inside intelligence, there's a branch of it. It's called machine learning. Okay, and under machine learning, we mentioned that there are 4 types of machine learning: supervised, unsupervised, reinforcement, and deep learning, right? So then deep learning. And the one that we'll be focusing this evening, so I'm painstakingly taking you through all the layers, peeling all the layers of the onion before you get to generative AI. So generative AI is part of deep learning, okay? So why is it called generative? It's because it generates new content, okay? It can generate new text. It can generate a picture, image. It can generate code. So people who are lazy and say, well, I don't know how good is the code that I wrote. So say, ask the thing to do it, okay? So code generation, music. They're not seeing the thing?
In Zoom, it doesn't show this.
Yeah, you can delete the bar. We can come back to it later. Yeah, that's good. Okay. Okay, so that's what generative AI. Generative AI again is part of deep learning. Okay. Okay, so there are two main types. There are many kinds because right now what we're living in a thing called multimodal. So you have text, you have images. Like for instance, right now, what is out there today, the two most prevalent methods are things like ChatGPT, which is a text-based generative AI. You also have things like DALL-E 2 or Midjourney, which you can generate pictures, right? So one of them is that you input text and then your output can be text. Like that's what ChatGPT is. You type in a prompt, you're inputting in a form of a text, right? And then the thing comes back and tells you everything you want to know about a subject. But you can also input text and say, create a picture of a person riding a horse on the moon. Well, on the moon, there's no horses. Okay. And but then you can say, please generate a picture of that. You can do that. So you're typing the text in your prompt. You say, generate a picture of a man riding a horse on the moon. Input is text. The output is a picture of a guy, riding a horse on the moon, and then he's actually seeing the Earth. The reason the way you manifest that is actually on the moon is that you see the person riding a horse on the moon, and then on the background is planet Earth, right? So that's a representation of that prompt. Okay. Now the other one is that you have image, so you can input to also the generative AI a picture of a photo, and then it says, well, tell me what this is. So the input is an image, it's a photo. The output may be a text that says, oh, that's a Bill, eating a burrito in the picnic. Okay, for example, there's the output. So the input can be an image, the output can be a text, the output could be an image as well. Right? And then if you animate the pictures, then you can input a image and generate a video. Okay, so that's an example of this. Okay, now one of the things that you'll be exposed this evening is that right now with everything on the cyber, so people are really worried about things because they say, well, people can steal my identity, people can fake that it's me or whatever. So with all the digital technology and the internet, one of the main things that people are concerned about is data privacy, data security. Okay, so generative AI is also good in helping cybersecurity. Okay, so here on the bottom of this slide, you see that you can detect certain things. You can prevent. You can secure that where you can double check that it's you. You can also make sure that it's not fake data. Okay, identity and so on. So AI can help you do that. Okay. Now, what are some of the other dangers and limitations? So basically, right now, what we're talking about right now, we're talking about generative AI, the pros, the cons, the applications. Okay. So the other thing about the dangers that I just talked about is that misinformation, that's bad. Okay. Or even creating something out of nothing. It's like what they call fake news. Okay. Right now, you can see a picture. Like for instance, they say something that there was like a people during a protest, and actually it's all made up because they just cut and paste pictures with a lot of people, and that thing actually did not take place. Okay, but it's made of fake stuff. Now the other drawback about this technology is that with AI, one of the other concerns people will say, well, do I still have a job? Because the machine is so Okay. Well, in that case, the real humans still cannot compete as a machine. The machine doesn't get tired. So, that is definitely one of the drugs. In that few years, a lot of people losing their. So, on the bottom of the page, the ones that are again going to get affected especially to text, like the, the paralegals. Okay, so right now a Hollywood serial script much faster in a matter of minutes. I don't have to pay anything. And then if I don't like it, say regenerate. Okay, so for a while there won't be any bank tellers. Bank tellers eventually are going to be all displaced. Because all the information is inside the computer. You go and give your ID and say, oh, I know exactly how much you have. And, all the stuff can be done by a machine. Okay, so those are a couple of limitations of on dangers of AI. It can disseminate false or wrong information. Okay, and also it can maybe take away some people's jobs. It's going to be a matter of time where almost every job is going to be affected by AI. But it's just to what degree and when. How far away is your job going to go away? Okay. Okay, so this slide captures the pros and cons. Okay, on the capabilities, we mentioned that tools like generative AI, like ChatGPT or DALL-E 2, you can generate text. So you can go and say, write me a paragraph on this. And it comes back in less than 1 minute, and here's a grammar perfect essay. Okay, and so on. Okay, so text generation, generation, you can answer questions. So before and not only that, but it's exactly what remember that before the what are the used to use the most? XYZ wiki, and then Wikipedia will come and tell you everything that people compile. Okay. But that Wikipedia still have drawbacks because it's not like a Q&A format. You ask for something within Wikipedia. First, it gives you 20 or 30 sources. You read all the stuff and make a decision what's the one that makes sense. Okay. So right now you say, what is nuclear fusion? The thing will immediately answer to you. It won't just give you a long paragraph with what nuclear. And on the side, there's a risk. So every tool with fire, you can cook your steak and you can have barbecue, but the fire can also burn your house. Okay, so for every good thing, there's also the counterbalance, which is not necessarily bad. It's a bad thing. So the risks of generative AI is that sometimes it's not always correct. And I will explain why that thing is not always correct. Okay, that's called, because right now the mechanism that they use is called LLMs, large language models. Okay, so if you are not into AI, well, you're going to be hearing a lot of new terms. Why is it that those things? Because the current method that AI is using is not based on reasoning. Okay, the machine doesn't know. For instance, let me give you another example. The word bank. Okay, bank. The bank could be where you go and deposit money and withdraw money, but the bank can also be the shore of a river. The bank on the neck, go across the opposite bank. Okay, so whenever you type a prompt, the machine, if you don't give the enough specifics, if you just type in the word bank, but you don't say anything about water or you don't mention money, it doesn't know which bank you're talking about because it's just based on a language. It just looks into the database and there's so many articles and so many sentences that use the word bank. But if you're not specific enough, the tool doesn't know what you're referring to. So that's the reason why it generates a lot of answers that don't make sense. Because if you don't provide specific data, it won't tell you what you're asking or inquiring. Okay, so the other thing is that right now, and this is something that if you're interested during the Q&A session, you can ask me all about ethics and morals, what's right, what's wrong. Right now, all the scientists are busy providing the data, but they're forgetting one thing. They're not teaching the computer what we've been teaching to our kids when at home. You tell it, okay, don't do that thing, don't steal, or don't lie. So people have not been doing that. So that's the reason why the machine doesn't have moral, doesn't have ethics. It doesn't know what's right from what's wrong. Okay, because in the literature, you have good things and bad things. Like for instance, if you feed one of the books to the computer, and you feed it Machiavelli, okay, which is like the guy who is already scheming and trying to kill the person, and so on. The machine also learns that, okay? So how does the machine know what's right, what's wrong? You just feed in data, okay? So that's one of the risks about the machines. Also, privacy and security. So on one hand, you want to give them as much information to the computer so it can help you with your own personal problem. But you're also you're exposing yourself by telling too much to the computer. If your data gets lost, like for instance, right now, the thing that also always happens in the email, say, oh, Norton tells me that, oh, somebody else stole the data from this, Ramada Inn hotel. They don't tell you that you have prevented something, but they actually tell you all the problems that they're trying to have. Okay, so privacy is important to each of us. We don't want people using our names in, doing bad things or using our money. So security, privacy is also important. Okay, and so is integrity. So we have our values. Each of us have our value system. What's right, what's wrong. Okay, but the machine may not share what your personal values are because they just got fed into a lot of data. Okay, so this one is a very busy slide, but it's not intended to be read. It just lists some of the applications and it jives with the slide that I said, which are the jobs that are going to get affected in the short term. So customer support. Right now, that's why I say, bank tellers, they will be gone in a year or two. Because all the information that they know, you can just teach a robot. And you pass all the information on Bank of America to the robot. And you don't need a person to, pay back to you all the things that they can do. Software development. A lot of people today, the machine can sometimes write better code than you do. So you either say, well, so right now people say, some of the low-level programmers, they say, a machine can probably do a better job writing easy code because at least they don't make mistakes. Every one of us who writes code, you may have a typo, you may not have the right label and all stuff. So all that stuff is gone. The other thing is that when you compare a human versus a machine, you can write your code and you can ask the machine to critique it. Say, okay, this one you have too many lines. You can do all the stuff in 10 lines in 3 lines, write more compact code. Okay, so that's optimization. Healthcare. The first application of AI in the robotics field is going to be in the healthcare. We're all getting old. The reason why I'm saying is because I'm old. So I'm saying, well, if I cannot count on my son and daughter to help me when I'm old, I'm going to rely on a robot. Okay. So robot, the first application of robots is to help the elderly. Okay. Because think about it. If you still have a surviving partner, let's say you have a spouse, don't forget your spouse is also old. So when you fell down, do you think that he or she can pick you up? No. As a matter of fact, that's what happened to my neighbor. I was one day at home. I hear the doorbell ring. And it was the neighbor, an old lady, come to say, Bill, can you help me? Because my husband fell on the steps and she cannot lift him up. So he asked me, another old man, to help him. Okay. So anyway, so healthcare is one of the first applications. Marketing. If you ask ChatGPT what you want to express, the tool can write in much better English than you can. You say, write me a promotional flyer about this drone. As long as you pass the information, the thing can do it for you. You can just enter the keywords and you go spit out a grammar perfect piece of thing. Okay, education. Program all the hard mathematics and then have the robot explain to people. Finance and environment, but also entertainment. So you can have robots actually entertain people. Okay. Make sure that I control the time. So among the risks, one of the risks that people always talk about is, I'm going to just focus here on one, is that, for instance, misinformation, okay? Also, what they call it, hallucination. Hallucination means that when the computer gives you an answer that doesn't make any sense, say, what are they smoking? When we talk about a person, say, well, I don't know what this guy is talking about. You say, what were you smoking? Were you smoking pot or marijuana, right? Okay, so whenever the machine gives you an answer that doesn't make sense, that means in this jargon of AI jargon, it's called a hallucination, okay? And what are the origins of hallucinations? Okay, so here you have 4 of them listed here. You are not giving enough data. So the model is only as good as the amount of data you give, okay? Or the second one is called noisy data. So whenever we're in EE, electrical engineer, I don't know how many of you are electrical engineers, there's a thing called signal integrity. Signal integrity means what's the real data and what's the noise. The noise, sometimes the noise is so much that it covers the actual. So the signal does not have integrity. That means there's too much noise, okay? You have not given the model enough content, or you have not passed on. Like, for instance, one of the things when I teach prompt engineering is that in order for you to be happy with what the ChatGPT or the machines tell you, the more information you give, the more specificity you give, the better you're going to like the answer. If you just go and say, well, just give you 2 or 3 words, you may not know what you want. So there's another thing about, since we're talking about ChatGPT and all this stuff, don't forget ChatGPT. Remember the word chat. Chat means a continuous process. Don't expect to enter a prompt and immediately get everything that you want exactly the way you want it. You have to continuously dialogue. That's what's called chatting. When I'm chatting with you, I start with saying, we're going to talk about AI. So we start talking about, then we say, well, let's talk more about deep learning, okay? And then let's talk about generative AI. The more specificity you give, then the more you're going to get the answers you like, okay? So it's not like you just give one prompt and suddenly everything comes back, the whole thing. It's an iterative process. It's a continuous dialogue process. So that's one thing that when I teach about prompt engineering, people think it's just like, okay, Wikipedia, just type in one phrase and then everything just comes out. Well, but you have to read everything and may not be what you are looking for. So remember, chat means continuous dialogue. That's what chatting means. Okay. Okay, so this one, I'm going to just skip it. Here, this slide just shows you some of the tools that are out there today. We have, like, for instance, chat models. You know, whenever you are going to and you ask a question and give you the answer, that's called chatting. So ChatGPT is right now the hottest thing since this November, December of last year. Okay, so we're around less than 1 year. Imagine, right now we're only October. So it's not even 1 year since ChatGPT came out. ChatGPT came out in November of 2022. Right now we're still in October. Okay, so you have ChatGPT. Then every competitor, you have OpenAI is associated with Microsoft. So Google also has its version, right? And so all the competitors have it. Right now, all the major companies have their version. Facebook has their version. Google has their version. Amazon has their version, right? And then the other one is the not only the text but the image. So DALL-E 2 is that when you say, okay, I'm writing a book and I need some illustration. So could you draw a picture so I can insert it in my chapter 2? Okay, again, the example is that the guy is riding a horse on the moon. So I'm writing a novel that has the guy traveling to the moon. So it can create a picture. Now the picture before it did not exist. You look into all the photos, there's no such a photo that's a person riding a horse on the moon, because nobody has drawn that. But you can ask DALL-E 2 or Midjourney to draw something that before it did not exist. So that's called creative or generative AI. Okay. I think I'm going to go a little bit faster, but just to expose some of the new methods, because some of the things that I'm covering tonight, unless you're a computer scientist, you may not know what I'm talking about. Okay, because if I want to dive enough, so one of the methods to create, how does ChatGPT work? Here I'm going to using need to understand everything. But one is called generative adversarial networks. So here, the only two words that you need to do is that there are two components of this method of GANs. One is the generator portion, and one is the discriminator portion. How do they work? This is the picture of the concept. Okay, you have something that you want to create. Okay, so it's a word or a picture. Okay, and then you have a generator that, because you are asking the machine to generate something for you, that's called generative AI. So what you do is that you feed into the thing to the generator, and it creates a sample. You compare against the real thing, which is the real world, and then you use this discriminator to tell the difference between the real thing and the thing that is generated. If the thing that is generated is far off from the real thing, you say this is not good. What you created is far away from what I want. Okay, so it keeps iterating until you say, okay, now it's getting closer. So what it does is that it measures the error between the real and the ones that is generated. Okay, and you're trying to minimize the difference of the error. So whenever you're getting to 0.01%, say, oh, I'm happy now with it, because this is what I want. Okay, so that's called the GAN, generative adversarial network. So that's what it stands for. Okay, now another thing that people are, especially ChatGPT, it uses this technology called transformer technology. Now for the kids, or for our kids, for people who have teenagers, remember that there's a toy, or so many toys that are called transformers. Transformers are the tools that you can use like a car, and then the car can become a robot. Remember those movies? Yeah. Okay, so that's called the Transformers, right? The Optimus, whatever, I think one of the main characters is that, yeah, a car can be converted to a robot and so on. That's called a transformer. So transform in the AI lexicon is there are some key concepts, okay? One is relying on a word called attention. So that's no different than us. Whenever we see too many things, people say focus. Focus on, if you have 5 things, okay, which of the 5 things are you mostly interested in? So you put the focus and the attention on 1 or 2 of them. You don't look at all of it. You say, oh, I want the whole thing, okay? So the transformer mechanism is also based on focus, and it's called attention, okay? Now, the thing that is powerful about transformers is that normally when we deal with things, there are 2 ways to deal with things. Okay, if I give you 5 things, you can do it one at a time. That's called sequential. Okay, or you can say, you give me 5 things, I can work on all 5 things at the same time. That's called parallel. Okay, so imagine with the amount of data all the AI has. If you're doing one at a time, it's going to take you forever. Okay, so the reason why the transformer method is powerful is that it can process many things at the same time, simultaneously. That's the advantage of transformers. Okay, so for people who are really want to know the nitty-gritty of it, there's a paper called "Attention is All You Need," written by Google Brain. Google Brain is actually here in Silicon Valley. Google has at least 2 branches working on AI. One is called the DeepMind, which is the one that invented AlphaGo, the machine that actually played Go and beat the champion. Okay, that's in London. Okay, the other one here locally is called Google Brain. So this paper that tells you about how the attention mechanism works, it was written here locally in Silicon Valley back in 2017. So that's only 5 years away, 5 years ago. Okay. And the transformers, what they're good at, they can do text classification, they can do translation, they can do comparison, they can generate the things very easily, text generation. Okay, so all these are what transformers are good at. Okay, so all of this, text generation, translation, Q&A, is like when you ask the question, you'll give you answer, that's Q&A, classification. Okay, and also you can give it a book and say, summarize all the book for me. So if you're lazy, I say, I want to know about the book without reading it, you can ask the ChatGPT to give you the summary of it. Okay. Okay, so now we're pausing here. We're talking enough about generative AI. So let's talk a little bit about everything else that goes around AI. We're going to talk about cloud AI, edge AI, model-centric AI, data-centric AI. So I don't know where you have, you know enough about cloud. You probably heard about the cloud. The cloud is not only the natural cloud that is above us, over our heads, but cloud means that if you don't have enough money to have your own large mainframe, so let's say you want to do something that requires a lot of computers. You don't have, not everybody can afford a Cray or a mainframe, right? So you say, well, I don't have to buy my own mainframe, whatever, Yahoo, and they have servers that you just pay a nominal fee, or sometimes they're still free. And then you can have all the computation, all the servers and the farms are all the large computers are sitting there. And we're all sharing that. Okay, you have a Yahoo and a Google account. They don't charge you. But imagine how many Google emails you have per year. Probably thousands, right? And they're not charging you for keeping your all email. Okay, so there's the cloud, and the opposite is the edge. So what is a, and let me illustrate what's an edge for the people who are not familiar with what's edge. So cloud means unlimited. It's far away, but you have unlimited computational power. You have unlimited storage. The edge is that, for instance, you want to a fast response. Let's say the most typical example that I give on edge is that driverless cars. Okay, so let's say you're going to have a car that can drive by itself. You don't need to have a driver. Okay, so the information that it requires is that somebody could be stepping down from the sidewalk in front of the car. Okay, now if it doesn't have a driver, the car needs to know when to stop, because otherwise it runs over the person walking there, right? So imagine that if you have to make a decision, say, okay, my computer vision tells me there's a person now stepping down from the sidewalk, and then you have to send that information back to the cloud, and then you're waiting for the cloud, and sometimes you may not have access to internet, okay, or doesn't respond to your time. By the time you get a reply back from the cloud, you already ran over the person. So that's why the edge means that when there's a new term called latency. Latency, it just means the amount of time that it takes to respond. When you go and put in a request, when does the answer come back? Okay, so there's a lot of applications where the latency is very, very short. You need to be able, within fractions of a second, tell me, I don't need to apply the brake, because otherwise you already ran over the person. You cannot afford to go and send the message to the cloud and wait for it to compute and come back to you. So that means that all the computation and storage has to be on the device itself. In this case, it's in the car. Okay, so you don't need to send the information back and forth to the cloud. Okay, that's called the edge. The edge is on the device. Okay, so I'm going to go a little bit faster because I have a lot of things to cover. So on the cloud, mostly right now, everything related to cloud is a service, because, like, for instance, you have email, you have buying things on Amazon or whatever. They don't charge you. Well, they charge you some of the things, but not most of it is actually for free, because they encourage you to use it. So the cloud is sort of like a sharing resource. So you buy it in the form of a service. Okay. Okay. The edge, on the other hand, the emphasis is different. The emphasis is on latency. You have to have short latency. Query and response within a matter of seconds. Okay. Okay, so that's that. Okay, so right now, how's everything related to a model? Whenever you have a model right now, you have the model and you have the data. So right now there are two camps. One is called model-centric AI that says, okay, well, how do I tune the model that I have in my AI machine? Okay, the other one is to say, I'm going to focus on the data. I want to make sure that the data is correct, has been validated. Okay, it's not fake data. Okay, and so on. So if the emphasis on that, then it's data centric. So you have, on one side you have model centric AI, and on the other side you have data centric AI. Right now the trend is to go toward the data. Okay. So one word about data. People say that right now the AI is sort of like a new engine, it's new machine. But even like our cars that we drive, the car doesn't move if there's no gasoline on it. So the same thing with AI. You have no data, AI is useless. Okay, so AI could be your next machine, but data is your new oil. That's the way you draw the analogy and the importance of both. Okay. Okay, so second stop. Right now, I'm going to get into the things that maybe not many of you have heard about. So some of you maybe say, well, I just came to hear about, not about generative AI. I know all about it now. I want to hear about the new stuff. So here are the 7 or 8 new technologies that you may not have heard about, okay? So I call it emergent AI. Emergent AI means that it's just born. It's just beginning. Some of you may not have heard about it, okay? But you're going to be exposed about it. So there are 7 or 8 of them. Okay, so this summary of the 8. First, there are certain categories. You can group into certain categories. The first, principles AI, that means that you worry about the things that are important, the foundation, okay? Also, make sure that AI is responsible. So this goes into the category of, is the machine doing something that is ethical, that is moral? Because whenever, let's go back to the driverless car. Is the driverless car the driverless car, or the company that put out the driverless car, or is it Uber, or is it the company that is using that as a service? Who is responsible for it? Okay, and also, are you having the machine do the right things, doing the responsible things? So when we go out there and do our things daily, you're responsible for yourself. You're over 18, you do bad things, you're responsible. You do bad things, you are also responsible, right? So machine, who is responsible? So either you have to impart the culture of what's wrong, how is it wrong. Okay, the solution cannot rely on one single technology. You have to combine several of them together to give you a composite. Composite is made up of more than one. Okay, and one example that we'll give later on is called the neuro-symbolic. Neuro means the way that is based on how our biological brain works. It's called from neural networks, because our brain is made of neurons and it's based on neural networks. And symbolic is made up of our reasoning. Okay, so all based on our education, we know what's right, what's wrong, and so on. Okay, the other thing about the worries about privacy is federated machine learning. Okay, so let me just define what federated means. I'll get into it, but if I do it here later on when I cover that slide, I'll spend less time on it. So right now, everybody, when we file taxes, you have 2 forms: the federal form and the state form, right? You have to file federal taxes, and you also have state taxes, right? So federal means the central, is that it applies to all the US, okay? The state, you are living in the state of California, so you apply the taxes that correspond to California. But if you're living in Texas, you're paying maybe no state tax. Okay, so we'll get into that. Okay, so there are 8 new ones. Let me just quickly go over. The first one is called Causal AI. So we mentioned that a lot of the new methods the machine learning does is based on LLMs, large language models. The way that large language models work is that you give 2 words or whatever is in your prompt. You give 2 words, 3 words, or a phrase or a sentence. And the machine takes all the words that are in your sentence and it figures out what's the next word that will follow. So the way that the machine AI generates the answer for your query is based on the letters that you provide. And you look into the database that has read all about the Wikipedia, it has read all about the many, many books, the most famous novels. And then it looks at how those words were assembled and put together. And based on the knowledge and domain that's made, it's going to give you the answer. But it does not mean that the machine has reasoning power. It's just playing with words. So right now, the current method of LLMs is also called next word. Is that you give 3 words, what's the 4th word? You have the 4th word, what's the 5th word? That makes the most sense. That's the way the machine works. So sometimes it may create something that doesn't make any sense at all, okay? But the causal is that it worries about the cause and effect. If you do this, this is what the effect. If you do good, you're going to get good reward. If you do bad, you're going to be penalized. You're going to go to jail. So that means that it has your action and what you're getting in return. So that's causal, okay? The cause and the effect. So if you think about it, if you use causal AI, that's why people are spending time on causal AI. It's because now, if you have causal AI, the machine will work more like what a human would do. Otherwise, you're just playing with words right now. It doesn't make any sense. Okay. Now, the reason why right now ChatGPT gives you good answers is that it has, gazillions of data. It has put in all the information. That's why it takes a year and a half to impart all the domain knowledge to the chatbots, to the ChatGPT. So everything that is out there that people have written is in there. Okay. That still doesn't make sense where it's right or wrong or true or false. Okay. But if you think about, okay, if I rob a bank, you go to jail. The cause, you have the effect and say, oh, okay, well, if you go over a red light, you're going to get a ticket. Okay. That's the cause and what's the effect. So if you know that, then it makes the machine more like us. Okay, we know the why. So that's why it says the how and the why. That's what the causal AI is. Okay. Okay, the other thing I mentioned is composite AI. Composite AI means that very often the answer does not rely on one single thing, because the answer may provide you only part of your answer that you need. Okay, so sometimes it takes together many things to put it together in order to make it a solution. So let me give you the picture example. So let's say you're building a house. In this case, I'm just using two geometrical figures, a triangle and a rectangle. Okay, and then you say, well, draw me a picture of a house using the triangle and the rectangle. Okay, so the building block is the triangle and the rectangle. But if you have more than one, then you can draw a picture of a house here that has a roof that is in triangle, because most of the roofs are like shape. And then on top of that, you can draw a chimney. The chimney is all made up of a triangle and rectangle. Okay, the window and the door can be rectangles. Okay, so very often you require many building blocks in order to come out with a solution that will meet your needs. Otherwise, if you just have only a rectangle, well, then everything is a rectangle. You can still have a building, but it doesn't really have a good aesthetic shape. Okay. Okay, so that's composite. So the composite AI means that here are what I call the building blocks. So like in the other slide, I have a rectangle and a triangle, right? These are some of the components that you can mix and match. So you can have data-driven AI, you can have symbolic AI. Data-driven makes no sense of it, just gathers the data. Okay. The symbolic AI infers some reasoning. Okay. Then you have logic rules. Then you have also machine learning methods, the many machine learning. So just today we probably cover 7 or 8 different machine learning methods. If you know only one, if you only know supervised learning, well, your answer is going to be much limited because you cannot leverage a lot of other techniques. Okay. Language processing. If you feed the ChatGPT the top 10 languages that are being used in the world, you have a lot more data because you have books that are written in Chinese, some that are written in French, okay, some in German. If you just give it only the books in English, then the amount of knowledge in that is much less. Okay, so first principles AI. So I capture more or less in the first sentence. First principles means, remember, like when I talk about transformers, the focus on attention. Attention is all you need. Well, the first principle means that you recognize what's the important things, what's the foundation, the foundational things. Okay, so people, a lot of times people say, well, you ask a very abstract question, And then very often the answer to that is not existent, does not exist in the physical world, okay? Because they just rely on concepts. Okay, so first principles AI, it sort of combines both. Not only get an answer, but it also gives you an answer that makes sense within the context that you're looking for. Okay, it has to be physical. It has to exist. Okay. So for example, the example I always use, man riding a horse on the moon. That's not physical because there's no horse on the moon, right? And so on. So, but if you have first principle, you say, oh, by the way, you're asking me to do something that it's not physical, it's not reality. Okay, so you factor that in. Federated learning. Okay, the only thing a message I want to get from this slide is that it is one of the most beneficial is called the data privacy, because right now people are worried about data security and data privacy, right? There's a lot of startups here in Silicon Valley that are working on it. Okay, so what is federated learning? So remember the analogy I draw between the federal government and the state government? Okay, normally the way that the machine learning does is that you have something sitting in the cloud, the central server, because that's where all the storage is and that's all the computer power is. So the way that people will do it is that the central location will issue an order to all the states or all the components, and they will ask for all the data to be sent over to the federal government. Okay, but that is not always realistic because people say, well, I don't want to send my personal data to somebody else, right? So the way that the federated learning is that the central repository sends you the parameters that you need to the local nodes. The local nodes don't have to send the private data back to the top, to the central. It just processes all the examples within the local level. So in this analogy, it gets done only at the state level. And then the results without the individual data gets sent back to the federal. That's what is called federated learning. Okay, so the model gets sent from the central to the states. All the information gets processed within the states, and then the results without the individual knowledge gets passed back to the central or federated. Okay, so that eliminates some of the problems about privacy. Okay, one of the things I mentioned about earlier was called composite AI. That means that you append more than one solution and you create a bigger solution that is more powerful. Okay, so one of them is called neuro-symbolic. So remember that when I mentioned about ANN, artificial neural networks, that's just the way that our biological brain works. It's made up of neurons, and neurons provide stimulus to the next neurons, and there's a neural network. So you're trying to create a model that resembles what our model on our brain is. So that's neuro. Symbolic means that it's just a concept, okay? So, but symbolic means that you infer some understanding and reasoning. You know why. So if you do it only based on the neurological model, you're going to get something like what we have right now, the large language models that sometimes don't make sense. Okay. If you had symbolic, that sometimes is good, but there's not enough data. Okay. So by combining both the neuro-symbolic, it takes away it complements and eliminates the limitations of using only a single model. It has more than one. And also doing that way, the output, the outcome resembles more a decision made by a human. Because when we do based on our own personal education and background, you make a certain decision based on your own personal background. So your background may be completely different than mine, but you make your decision whether it's right or wrong based on whatever you are being exposed to. Okay, but at least there's some rationale behind it, why you're doing this thing. Okay, so it's more human-like because it combines both the symbolic, not only the neurology, not because even right now, all the people who you see all these gurus, AI gurus right now, people saying, well, I'm not sure, maybe, one day the machines will take over. There are a lot of people, there are two camps right now today on the AI. People that say this is the end of the world because the machines will surpass the humans. And people say, no, you don't need to worry about it. There are two camps, right? Why? Because right now, based on the ChatGPT, all the experts who created the large language model, they were themselves all surprised by how powerful the thing is. So it way exceeded their expectations. Say, I didn't know that the machine can do this thing. When I created, I just created the algorithm, but based on the data that they capture, it can do things that way beyond what they expected. So they say, we're losing control. That's why all the, all the godfathers of AI, they're worried about it. So, well, I don't know about this. Yeah, another few years, we don't know what the thing can do. Because they say, we probably are losing control. Okay, and that's back to because if you don't, and anyway, I'll cover that in the maybe Q&A session. That's more philosophical. Okay. So neuro-symbolic AI. On the left side, you have the way that the neurons work. There are billions of neurons in our brain, in the human brain. Okay, and one neuron excites the next neuron, and so on. They have layers and layers of neurons. And then the other thing is what we are educated and you learn about what's right and what's wrong. You learn about symbolic things. Okay, so the neuro-symbolic is combining both. So by doing this combination, the output of the AI will make more sense to you. Okay, because it behaves a little bit more like a human does, rather than just a machine. Okay, so the neural part of it is the way that our human biological brain is called human brain. You have human brain and you have AI, artificial brain. Okay, so neural part is the way that our neurons work. Okay, but you have to add to it knowledge and reasoning. Okay, so if you combine it, then it actually becomes more like us. We actually don't fully understand how the neurons in our brain work. People say, well, how can the brain process the thing? You have billions of neurons and they work very fast. I see something on the table and say, oh, whatever, there's an ant crawling there, you do something. The way we react, there are billions of neurons in the brain, but how did they work to come up with that decision that you do? People have not gotten to answer to that yet. So they just copy a part of the model. How does the neuron work? The input to the neuron, the output of the neuron, how the message propagates from one neuron to the next neuron, and then finally it comes out, reaches the decision. Okay, responsible AI. So this falls under the category is that if you want to control AI or the machines, you have to teach the machine to be responsible and to be ethical and to be moral. Okay. So the way I draw the analogy between when people are really worried about, well, what happens if the machine just goes rogue and it does a lot of things like start killing people, all the stuff. You know what the answer to that is? It's because the people who invented the machine, they didn't do a good job educating their kid. Just like, for instance, we have kids. And you tell your daughter, son and daughter, say, this is right and this is wrong. Don't do this because that's not good, okay? So when you have a machine, the machine now is your creation. But if you don't impart the moral and the values of it, then of course you cannot blame. So it's no different than the humans. We have good people and bad people. The bad people who are in jail, why? Because their parents did not spend enough time raising a good kid. That's why they wind up in that situation, right? So machines is the same. And we'll get more into the Q&A, more of the philosophical aspects of it. Okay, so I'm going to go faster. because it's already 8:15, so I'm supposed to be already wrapped up. So I'm not going to go every single item of the responsible AI, but when we talk about responsible AI, these are the 5 things that people worry about. Number 1, transparency. Because a lot of things people say, well, how did the AI make that decision? If you don't understand it, you cannot explain it. So you have to transparency. You have to, is it fair? Is it accountable? Is it reliable? And is it private and security? So I have a slide on each of them, but I'm going to skip all of those. Okay, but this is a picture that is interesting when we talk about fair. So 5 principles. One of them is fair. So look at the picture on the bottom. What do you think is fair? It's like you say, one way is to say, well, I'm going to give everybody the same thing. Okay, so you have a taller kid, a young kid, and a child. Okay, but the parents say, well, I'm going to be fair. So everybody's going to get the same box. Actually, that's the way that, just to tell you a personal anecdote. When I was growing up, that's the method that my parents were, say, everything gets the same. So when I was 14 years old, my brother was only about 8. My sister was 6. Okay. But when we go and get the meatballs, everybody gets 3. So the guy who really needs the most still gets 3. The kids that doesn't need 3 meatballs and still gets 3, because to our parents' criteria, that's fair. Fair means everybody gets the same. And I'm not critiquing where a decision is right or wrong, but there are many ways to make the criteria. So the other way is the one on the right side. You say, well, the tall kid, he doesn't need to stand on the box because he can still see over the fence. So why do you need to give a box to that? But the kid, even if you give 2 boxes, cannot see over the fence, cannot see the game. So you give 2 to the kid. So what's the fair? Is that everybody can share the game, can view the game? Or is it because, everybody has to get exactly the same thing? Okay, so anyway. So I'm going to skip all that. AI simulation. So right now, simulation, especially for people in electrical engineering, is that you have to, sometimes you have, AI is changing very fast, okay? And simulation also could be very expensive because, for instance, Bitcoin. Well, Bitcoin, in order to get a token, you have to spend a lot of compute power in order to get it, okay? So one way is, again, combine both. It's a sort of like also another example of composite AI. You have AI and you have simulation, and you combine the 2 methods and you come up with a better solution, okay? So you sort of reduce the shortcomings of a single answer. Okay. Okay, this is the last one already. So this is again falls under the category of privacy and risk. Okay. So people say, well, how can I trust AI? So this one and the responsible AI and the first principles AI, they'll all fall under the category when people are worried about what the AI produces. Okay, so in order to, when the companies issue, okay, well, right now is the version 5.0 of ChatGPT. Okay, right now it's under control because the companies who are issuing the tools, they are large companies, and they say if you're using ChatGPT and something goes wrong, okay, Microsoft is responsible because or OpenAI is responsible because they created it. Okay, but if imagine that all the AI is diffused everywhere, and you go and get your version of ChatGPT, and you put in some of your own personal data, and you don't teach the right values, then you can go back. Okay, so you have to have trust, like everything, you have trust. So summary and conclusion. So the good thing is that I'm still trying to wrap up. You guys are going to have a shorter Q&A session, but this is the last slide. So today, the focus is on generative AI. And people are amazed at what generative AI can do. Because before, who can say, write me a book, and the thing cranks out a book? draw me a picture that did not exist before. No artist in the past has drawn a man riding a horse on the moon. But now you can do it. Okay. So generative AI, it has done something that it has not been done in the past. It can create new things. Before, it was just like Wikipedia. You just feed in the information and they just gives back the information back to you. But it's not creating any new things. With the generative AI, you can create new pictures, you can create new music, you can create art, you can create poetry. So it's not being created, not just responsive. Okay. The other point in the conclusion slide is that, okay, generative AI is fine and dandy. We have now a very powerful tool. But that's like if you own a Ferrari, but you have the money to pay for the gas. So if you don't have data, what good is the tool? I think there's a YouTube video I just saw, is that they talk about all the rich people. I think this is an example in China. Say they bought this very expensive car because they are like, kids from a rich family, but they don't have enough money to put the gas in the car. So what good is it that you have a car that can go 200 miles an hour but has no gasoline? Okay, so this is another food for thought. So the difference is the data. Okay, now if you look at the current evolution, the current trend, is that people are putting less emphasis on the model. How many parameters we hear about ChatGPT? Well, it has 100 parameters. It has the data. It took about 2 years to give the data. People are worried more about the data, the quality of the data. So they're moving from model-centric, how many parameters and how many things it can create. They're worried more about, is it the right data? Is it correct data? It's not fake data, all stuff. And they want to clean up the data. Remember the signal integrity? You want to do away with the noise. Okay, so they're moving from model-centric data to data-centric data. And the ultimate is what? Human-centric data is what we need as humans. Okay, so that's I did not cover that, but that's also another topic that's out there. You're going to hear that terminology, human-centric. What is important to the person, to the human. Okay, so that's all. Still did it within 5 minutes of wrapping up, but it just means that less time for you to do a Q&A. Okay, by the way, just before I take the first question, right now, this is actually my third talk on AI. The last one I talked was on robots, okay, which is more focused on the hardware part of it. And the first one was on advanced AI methods. That was more computer science oriented. So the one that I covered today was actually more computer science, like with all the learning and machine learning and all that stuff. So the next one is going to be going back to a little bit more with the hardware focus. So I'm not going to be talking about robots, but I'm going to talk about AI chips, still related to AI. But what type of chips do we need in order to make the AI computation faster and so on? Okay, so that's what NVIDIA and Intel and all these companies are going to be working on, because they say, well, NVIDIA has got 80% of the market with the GPUs, right? Say, well, we need to do something about it. So everybody now is coming and saying, well, if I have a ChatGPT and I require hundreds and hundreds of GPUs that I have to buy from NVIDIA, why don't I go and make my own chip? So it's going to be cheaper. So this may be, again, this is still in the work, but this may be the next talk that I give. Okay, so I'll open the Q&A first to the people who are here present.
Thank you. Thanks everyone for attending, also especially to our distinguished speaker. A very insightful yet comprehensive presentation. One of the things you did talk about in the future lecture is about the costs of implementation and deployment, especially for client firms, for active users. What are the best practices do you think for maybe taking off-the-shelf solutions, training, buying the hardware, and really making a comprehensive cross-silo AI implementation because it seems for some organizations, especially small and medium-sized businesses, maybe I'm not innovative or entrepreneurial enough, it seems like a large undertaking, especially to hire consultants for it. So what do you think, just off the top of your head, are the best practices? Like
Okay.
5% of a certain, budget, or should it be tied to other factors?
Okay, I'm going to tell you the answer. Okay, so believe it or not, actually, I have all the answers. As a matter of fact, in my last talk, people say, by the way, I'm a walking ChatGPT. You don't need to log in to ask me the question. Okay, so I'm going to give you the answer. You know that way back in November of last year, when ChatGPT just came out, right? And people were so surprised and say, wow, this is the best thing since sliced bread. Okay. Why was that very impactful? Because the ChatGPT had evolved. Actually, if you think about it, before that, you already have AI that can play chess. You have AI that can play Go. You have AI that can do certain things, but it was restricted to only one thing. Okay, just like the Roomba. Roomba can only vacuum clean your house, but it cannot cut your grass, right? It cannot help you make decisions. So the reason why ChatGPT took over is to say, wow, I can ask just like Wikipedia. I can ask any subject and can give me an answer. Okay. Now, what we're doing now, what we are finding out is the following. Just like you don't need to have all the knowledge, you as a person, you don't need to have all the knowledge of Wikipedia, because only the ones that the things that you're interested in say, okay, what should I do and buy today? That's the only thing you need to know. You don't need to ask Wikipedia, because Wikipedia has all the information about art, about science and technology and everything. But your interest is only one segment of it. So the answer to your question is that we went from silos of capabilities, like playing chess or playing Go or doing some smart things, to suddenly ChatGPT that can open up for everybody. And that's why people so get excited, because, oh, I can use ChatGPT to help me do certain things, because I don't play Go. So what is good is it or that? So, but now it's going to be reversing, because as I said, you don't need to have, you have AI that can apply to, say, healthcare. You don't need the whole ChatGPT domain knowledge. You need only the things related to healthcare. So for the robots that will be working in hospitals, you don't need to have the knowledge about how to play music or how to play the piano. Okay, so that's the evolution. The whole evolution of technology is always just like the universe: expand and contract, expand and contract. So when we met ChatGPT, it was the expansion. Suddenly, not only can it do this, but it also can answer questions on, like, for instance, I don't play Go, but I'm bad in writing English essays. Oh, so ChatGPT can do it for you. Oh, suddenly you can. I'm not a good artist, but DALL-E 2 can draw it for you. So that's why people got excited. Now, when you go to the actual application, you need to go back to the individual domain, because you don't need a thing that can do everything. It can know how to go around the moon and circle back and know all about the gravitational forces. And you don't need to know. Your question is that from ChatGPT, the next evolution is going to be domain specific. Okay, because knowledge of Wikipedia, right? You only when you need it, then you ask. Okay, but you don't need to carry all that. See, why it takes so long. So getting back to your first part of the question, is the cost. Why is it that today there's only probably no more than 10 companies that have something like ChatGPT capability? All the ones that have are the large corporations, like Google, like Meta, okay, like Microsoft, okay, Baidu, okay, and those it. Why? Because those are the only people that have the resources to be able to afford training a general AI model. Okay, so anyway, I'll come back if you have a follow-up question. Any other questions that first? Yeah.
First, we saw the model of the neural network. And my question is, there's so many different, as we use, there's so many different forms of deep learning, there's transformers, there's deep, machine learning and basic levels of it.
Right.
How much of that is pure software from the perspective of just coding a model? And how much of it is hardware? What types of AI will require more memory, more processing, mathematical and depending on the processors.
Okay, so let me try to answer the question for.
Can you please summarize and hear the question with 1 to 2 sentences?
Well, okay. Let me see, because I did have my record button on. Asking is that when we talk about ANNs, the artificial neural networks, you have talk about deep learning, you have multiple layers, right? And it depends on the cost. So the more layers they can handle. Right now, it's probably into how that takes longer to train. Okay, but let me sort of like answer your question back a little bit. I think without even rephrasing the questions, I think from the answer, people from online can probably tell what the question was about. It takes a lot. It's very expensive to train a model. And in order for machines to handle deep learning, which is a multi-layer type of artificial neural networks, it takes a lot of computation time. That's the reason why my next talk is going to be on AI chips. Because every company that has a solution, they say, still too costly to me. Right now, they say that, I just read it today, they say it costs OpenAI 4 cents for every Q&A that they ask on the online. 4 cents. Now, people might say, well, 4 cents, what is 4 cents? But you know how many people ask OpenAI? So the thing is that in order for it to generate an answer, it costs a lot of money. And right now, only the large corporations can afford it. Okay, so the part of the solution is two-way. One is to the answer that I just gave the first question, is to say, cut down the domain. Don't try to do everything within one model. Okay, only restrict it to what, similar to the slide on transformers. Attention is all you need. Focus on what you need, and don't try to ask for everything. Okay, the other way to do it is in my next talk, is on AI chips. How do you make chips cost less? Because right now the GPUs and all things is very expensive. So all the companies that can afford it today, and I don't know about you, you probably know about the story about OpenAI, right? OpenAI, they were signed up by Microsoft. It's not like the Microsoft paid millions of dollars to OpenAI. What they did was that OpenAI rely on Microsoft server. So they are actually, when you read the news and say, oh, Microsoft spent, I don't know how many billions of dollars on OpenAI. It doesn't mean that they gave money to OpenAI. They say, okay, I'm going to give credit. So every time you ask a question and so on, you can use my server. So I'm going to, in lieu of that, I'm going to give you the compute power. Okay. Now, if the answer is still there, feel free to ask me a follow-up. I don't know, do you want to follow up on your question? Okay, yes.
I was wondering if I could apply there's a higher moral standard. An example would be let people in different states have a different.
Okay. So I'm going to rephrase the question and then maybe get to the key part of your question. Is that we're always worried about AI going bad. That's one of the worries about people. Okay. So one of the things that I mentioned when I was talking about reinforcement learning and so on, and also I gave the analogy is that the AI or the computer machine is not different than our own kids. Okay, so if you want the AI to behave and have moral ethics and have to impart the knowledge to the machine. Just like you, when you go and teach your kid or you send your kid to school to learn the good from the bad. Okay, so that's where reinforcement learning. Remember the thing I talk about, say, when you do something, remember that even the ChatGPT today, I can give you depend on the answer that you tell the tool whether you like the answer or not. So based on the feedback that you get. So one, that's not the right thing. And then the machine analogy between a kid who is learning from the parents what's good, what's bad, is that the machines, if you do the right education, like when we educate our kids, the humans, and if you try to teach the machine what's right and wrong, then you'll be okay. But it doesn't mean that there will not be bad actors. Because like today in our society, there are good persons and there are bad people, right? So the bad people are because the parents did not spend the time to raise a good wrong. So invariably, just like anything else, it doesn't mean that if I tell you today, oh, well, just use reinforcement learning or just use whatever to do it, it doesn't mean that every person is going to do it because each of us is different. So there are some people that value making money more than right or wrong. Okay. So anyway.
Some questions from the online.
Okay, we'll take one more here and then we'll come back.
Here we can stay as long as we want. Let's give a chance for the online audience because
yeah,
they are still in Zoom. Yeah.
Okay.
So Christina will
okay. Why do
So,
you said in the chat?
yeah, it says in the chat.
Yeah. She'll read the question for you.
Okay.
So
Fine.
one of the question in the chat is, please explain how jobs lost to food service.
How jobs are lost?
To food service.
To food service?
Mhm.
Okay, actually, that's a very easy question. So do you know that today, if you go to a restaurant today, so this is not like tomorrow or next year. If you go to the restaurants today, they all have this, it's not like a robot that looks like a robot, but it's a machine that goes around. It says it has all the plate that gets loaded from the kitchen and it goes around the tables. And so they're already, and also the other thing is that there are machines that take your order. You don't need to go and have a waitress come and serve you. What do you want to order, right? You can do the order online on your desk, right, or your phone. And then you can also have the server. The server actually is a moving cart that goes and stops at your table number 5 and say, okay, you order curry chicken. So here it is. So that it is already there. That's one of the areas that first will be applied in AI. The food service and the healthcare, those are the two probably the most immediate because that's prevalent. That means everybody needs to eat. So that's the first application. It's going to be on that. Yeah, next question.
Another question is, I wonder if personal data security or data protection can be implemented with certain mechanism during DL model generations, since more powerful chips like A100, B100, H100 embedded in servers.
Yeah, so that's a hard question to answer because I don't know what every company is doing. Okay, so back to the general premise that I mentioned is that why today I'm not too worried about the tools that are out there because all the ones that have the tools out there, like the Microsoft and the Google and the Meta, they are large corporations and they cannot afford to let their tools do something that is out of line, right? So the question to this question about security, privacy, is that when you have a responsible organization, then they will go and do a responsible AI. Okay. Now you cannot enforce it. It's very hard to enforce. So that's why I say, I don't know of what every company, if you ask me, well, what's Microsoft doing about? What's Google doing about? They're probably all doing different things because it depends on their management. What is most important to them for them? Yeah. So that's a hard answer to give. That is a general answer because every company is doing different levels of efforts. Okay. So let me go back to her and we'll come back to you. Well, do you know that, have you heard about right now, there's the people already saying, well, in another few years, there's no need for income because the people don't no longer need to work, okay, because all the machines will do it. Now, that is not going to be in the next few years. Okay, that's going to be far away. But people say, remember, have you heard about this basic income? That means that nobody needs to work because the government will make sure that everybody can have something to eat, okay? But it will get worse before it gets better. Because if you look at the problems that we have today in society, is the disparity between the haves and the have-nots. And that will be compounded even more before we reach to that level where, oh, nobody needs to work. So what do the humans do? They don't do anything. And even look at today. When you think that you are at home, so it's great because I don't need to do anything. I have money, okay? Think about it, just like any tool. While you think it's good, it may not be necessarily be good. Because if you're doing inactive, then you're going to have a bad health because you're not doing anything. Your brain doesn't work. You don't walk around, you don't do movement. You may even die earlier, even though you don't have to work. So that's why I say, why all the books I wrote is on philosophy of life. You as yourself, as a person, need to determine what is good for you and what's bad for you. Have all the latest technology. It doesn't mean that it's necessarily good for you. Okay. So anyway, that's the. I'll leave it at that. Come back
Well,
to.
last question is pretty simple. So, Dr. Kao, thanks for the excellent talk. May I ask, when are you planning to talk about the AI chips?
AI chips. I started today. Normally, it takes me about 1 or 2 weeks to get together a presentation. So it doesn't take me that long because I'm retired. I don't have a AI that helps me doing that, but I can do it all myself.
I have a recommendation for you. There's a company out there that makes slides based on the
Yeah. Actually, I actually asked ChatGPT to create the outline for me, but the work itself, actually, I do it myself because actually I do it faster than the ChatGPT guy. The reason is the following. Remember the thing about the feedback is that let's say that they say, okay, ChatGPT, create me a 30-slide presentation. The thing that it creates may not be exactly what I want because everybody is different. When I give a presentation, it has to follow my line of thought and so on, right? So what ChatGPT cranks out for you, it doesn't necessarily mean that it's the best thing for you. So only you know exactly what you need, okay? So when I start the way that, for instance, I do a presentation right now, I actually go and say, okay, I want to talk about AI chips, okay? So I will ask Fred, okay, why don't you give me an outline? As a matter of fact, usually before I ask ChatGPT, I have in my mind what I need to cover. What are the 5 things I want to cover in that presentation? And then you say, okay, create an outline. And then you'll create, and then you have to be very specific. I want 30 slides or I want 50 slides. Okay. And there are a lot of things that the thing cannot do for you. As a matter of fact, if you look at ChatGPT, you can create a lot of the, as a matter of fact, the way I also say, create a slide in PPT format. So it's already in bullet form, okay? And then it gives you a lot of suggestions. Like here, you may want to insert a picture. Okay, so the coordination between, say, the image creation and the text is not completely there. Okay, but I think the thing is the following. Just like anything else, what you need only is different from person to person. Even when we say the 2 of us today are being asked to give a presentation, the way that the slides that I generate are different than the ones you create because each of us is different. It's unique.
In addition, the mention of the focus of AI is switched from the model thinking
AI to data-centric AI.
Mhm.
Do you have an idea on general principle to control the data quality, data creation, especially for startup, also don't have much resources to have people to
Okay, so the question was the model-centric AI versus data-centric AI. Right now, the general trend is going towards data-centric, okay? Because they find out, this is by doing all the companies who are working on AI tools, they say that if you add another 1,000 parameters to think, make the model more complicated, or you want to fine-tune the parameters, the benefit is not there. It's better to give more data. Okay, this is just a empirical data that say if you give more data and better data, and you, what I used the word was curate the data, means that the bad data you eliminated, the noise you eliminated, okay, and there's also called synthetic data. Is that because very often you are creating something that don't have data that exists out there, okay, so you have to generate new data in order for the model to have enough data to work on. But the answer to your question is that that's just an empirical model. People say is more efficient and more effective to work on the data than rather than fine tune all the parameters of the model. So that's why it's moving from model centric to data centric. And the data centric is not the ultimate either. It's that depends on what you need. It's that what does the human need? Is that you have to, that's why you say, whenever we give a prompt, is that you tell the computer what you need. You're not just asking a generic question. Okay, so right now, everything, if you look at a lot of papers right now on AI, they are all focused on human-centric AI. That means the focus is based on the person's needs. It's not just data per se. Okay. Okay. Question.
This will be my final question.
Okay.
So I think a lot of the AI that we're talking about here largely is very much heuristics, where you are trial and error, trying to find the best approach to get the best data. So there isn't necessarily a model, a scientific method from point A to point B that will populate everything for you to understand the picture of what's going on in that neural network. I think that beyond from the tensor processing that we do, etc. It's like steam engines in the 1700s, and it took us 100 years for Kelvin to come up with the thermodynamics equation, which explained how the steam engine worked. So is that basically what it's seeing here with the AI revolution? The trial and error, and we have a specific model to combine everything to truly understand what's going on.
Okay. Actually, this is on paper. That's what is happening. Is that you cannot tell the real data from the bad data, or what's useful data versus just data and more data. Okay, and that's why I keep reiterating. Don't rely on AI or any tool to do everything by itself. If you don't give the feedback, it's never going to meet your requirement. Okay, but so this is, if you look at reinforcement learning or any of the learning, is that we humans have to interact with the computers and tell what we need. Okay, the computer by itself, if you give gazillions of data, it's not going to know what to do with it because it just has a lot of data. But if you don't impart to the computer what your criteria is, it's never going to know. So the way to cure is very simple. Just interact with more specific information to the computer. So the more specific data you give the computer, that's why I say, this is part of my prompt engineering part of the course, is that the more happy you're going to be with the results like this. Okay, so it's not the amount of data. This is a talk that I used to give on big data. We live in an era of big data. That means that there's so much data, but what good is it? You say, okay, give me all the essays on AI chips. Well, you have 500 essays. But you as a person need to go and say, what, this one is just garbage. Okay, this one is useful. This one is just, oh, this does not give deep enough. But this person, if you get the information, it may be different because the amount of knowledge that you have is different than he has. Okay, you may have more knowledge or less knowledge. And for him, say, this is so trivial, doesn't make sense, you know. And then you may say, oh, this is very useful data. One anecdote, because I've been teaching, you know that, you know, Chinese, one of the famous people in Chinese is Sun Tzu. He's the art of war, okay? So when I taught that course, I read all the books, probably about 30 books on that subject. Some were addressed to kids that were less than 14 years old. Some of them were actually officers in the Chinese army who went to university to learn from the professor. Okay, so what I'm saying is that there are different levels of degree and everybody is different. When you explain to a first grader, you need to explain it in the way that he would understand it. But if you explain it to a person who is attending military school within the army, you need to go at a different level. So all of that, it has to be adjusted. Okay, but right now, the data is all completely out there. You have to go and say, this is what we need for this audience. Okay, so most of the things I talk here, when, like for instance, tonight's presentation, I actually tailor for people who, some people are working on AI at Meta, at Google, whatever, they still come and listen to my, you know, bubbling. But then there are other ones who are just housewives. Say, oh, you know, I keep hearing about AI, you know, what is AI, you know? And then I would tailor for everybody. So that's why when I start, I also start with the definition of what's AI. Okay, so that different people have different needs. And you have to tell it what you need. So when you go and do chat prompt engineering, one of the things that you have to do when you do the prompt is to say, act as an expert. So then you are expecting, okay, the answer to this guy is going to be more like a college level answer. Or to say, explain this concept to a 10-year-old, okay? So you have to specify what level you want. Okay, so we live in an era that there's so much information out there, but if you look at it, and that's the reason why I say, if you come here and listen to me talk for 1 hour, at least everything is already condensed. If you look out there, you're going to be spending hours and hours on garbage, okay? And it may not be at the level that you want, because you may already know more than what the guy is talking on the YouTube. Or you may be too profound that you don't understand what the thing is. So the data is all out there, but you have to go and pick and choose what's the right level for you. Yeah.
Yeah, can we have one more question?
Okay,
Sorry
more
about
question.
that.
One more question from online.
So, does ChatGPT have certain prompts to use to communicate to ask ChatGPT to perform the things that I want? Is there any resources we're talking about those prompts?
Actually, I have a course on the prompt engineering. Actually, people originally I was thinking of giving a course because as I say, I taught at the UC, University of California here in Silicon Valley. And right now, since the start of ChatGPT in November of last year, I've been preparing a short course. Short course means that it's not like a whole semester or a whole quarter with 10 classes. Okay. So just like today, if you look at today's talk, starts with generative AI. Generative AI and beyond, right? That's tonight's topic. When I give the short course, it can start with AI, generative AI, ChatGPT, and prompt engineering. So it depends. I can cover 4 subtopics, or I can cover 1. So right now, everything I was talking to Jens to a little bit earlier, say everything that I have is modular. So you tell me what are the things that you want to know, and I'll assemble the blocks. Okay. Okay.
This is taking a little bit of time. So when I went to school, I went to MIT back a long time ago, and I did an electrical engineering and computer science degree. 6001 was the entry level course where we learned Lisp, and it was the machine learning code that helped us understand how to control the hardware.
Sure.
Today, when you look at the engineering students, they don't start at that level. Their first course is Python or something else that's higher abstract level. And I sit there and think, how do they do that without understanding the details of machine mechanics of how to use code to control the hardware? And their philosophy is that that's no longer needed because they can think on a more higher abstract level that helps them do some things that are happening now, which is really, it's fascinating. What you talked about with the
So let me answer just up to the things that you just mentioned so far. Remember on my last slide, there's this thing called human-centric AI.
Yeah.
When we went to school, I predate you because when I went to school, it's Fortran. So that was before even Lisp came out. Fortran, PR1. That's when I did. And before that was assembly language. Okay. So the thing is that why right now is a one word. They call it one word. When I talk about digital technology, the word is called democratization. That means that for you today to try to learn a language, you don't need to be a computer science. You can learn it in a plain English. Try to learn the thing. So it's no longer say, okay, well, I'm going to take Lisp. So say, well, I have to take CS 101 first, and then know what the data structure is, and then all the databases. Remember, those were the days when we went to school. Right now, you want to learn language, they will just say, as a matter of fact, the programming today, just program in basic English. You just tell it, do this, and then the thing will create the code for you. So you say, give it the instruction and say, give me the answer in Lisp, or give me the answer in basic, or in whatever, Fortran. So you have multiple mapping, but it's still doing what you want to do.
So I think what's interesting about this is that to some degree it starts to turn off specific things about our thinking, but allows us to think differently. Like instead of having to know the mechanics of things, we can think about things. So I remember seeing this one image.
Let me just also make a comment on what you just said, okay? Because I give the same answer in almost every lecture I give. We are all car drivers. We drive our cars, right? But if you ask all the people in the audience, how many people know how to change a tire? Or how many people know how to change the spark plugs? Not everybody's at the same page, okay? But in order for you to drive a car, you don't need to know all the mechanics. That's the point. So right now, AI is at the level where everybody can take advantage of AI without being a computer science guy. Okay, so that's the answer that says right now, the reason why the beauty of it is that you don't need to be a guy who really knows technology in order to use it. So not everybody's a car mechanic, but everybody drives a car. So you know how to use it, it's good enough.
So you were talking about we're moving towards the basic. I've heard that as well too. Basic income, we all don't need to do. But I feel like there could potentially be abstractions of what we do as functions. We're human beings. We're going to want to be able to do something. We have a purpose. So the idea of just sitting back and letting technology do everything and we just kind of enjoy life, I have a hard time with that when we want to be able to think about what. So there's potential that we may morph into doing more and better and different things that we don't really kind of comprehend right now. The careers that exist now did not exist when I graduated from college. So that potentially could be where the world is going, is like as AI starts to take over some of the fundamentals of things, the fundamentals of human life, we may morph into additional or, next generation humans potentially, or we could become obsolete too, depending on how,
Okay, so let me also make a comment on that. Actually, all this is easy answers for me because I started with philosophy of life. Okay, when you say that, let's say one day you'll retire. Well, I don't know where you're already retired or you're about to retire. And you say, well, what do I do when I retire? I cannot just sit in the house doing nothing. Okay, so what I do, for instance, is different than what you would do. Okay, so for instance, the reason why I'm giving lectures here is because that's my interest. My interest in educating and promoting the information and the knowledge to as many people as possible. I'm not getting paid to do that. Okay, but that's my interest. You say, remember that in my summary of my resume or the speaker's bio, the last sentence is Bill is a technology watcher, learner, and teacher. That's my interest today. I don't need to make more money. I have enough money for the rest of my life. But I'm interested in learning new things. So that's why technology, I watch what's new, okay? And then I try to learn it myself. And then as a proof of what I know enough, is that I will teach it. So that's why today I'm giving you all this talk about that, okay? So now everybody's going to be different, okay? And guess what? Another personal anecdote is that when I retired, I was my major was electrical engineering and electronics. I worked in semiconductor industry for about 35 years. When I retire, I say I no longer want to do anything with semiconductors. I want to learn more about chips and then EDA and all that stuff because I've already been doing it for 30 years. Then I found out but before that, I didn't know what was lay ahead of me. But then I found out that actually scientific knowledge. So I went from semiconductor to clean technology. So this is actually my third generation of knowledge already. Third wave. My first one was semiconductor. The second one was clean technology, like solar, wind, clean water, and all that stuff. And right now it's emerging technology because I already graduated even from clean technology. I already gave all the talks on solar and all this kind of solar, the wind and the water, the biomass, everything I've given already lectures on that. So I say right now all the talks that if you look at my last 5 to 10 talks have nothing to do with clean tech. I talk about Starlink, satellite communications. I talk about AI. I talk about nuclear fusion. Okay. So robotics. So the thing is that I don't necessarily have a plan for what's going to be next. But I found out that there's always something new that I can go on. So the thing is to pick the right area. That I have enough background, for instance, in both hardware and software that I can pick up a subject and try to understand it. And before, in my past life, I was an R&D guy. So that means that everything that we develop, the product, like software or hardware, is all me learning, reading from somebody else's paper and try to implement in a product. So after I retire, I'm still doing the same thing today. I read a paper, pick up a paper and read it. And the other funny thing about it, talking about all the math that, that when I went for my PhD, I took all the math courses of all the mathematics department. So even though I was electrical engineering, because my advisor was away for about a couple of years on sabbatical. And during my whole engineering career, I never used integration. I never used differentiation. I never used a lot of things that I learned in grad school. The only thing I learned used in the engineering, trigonometry, algebra, geometry, and those were used. But today, I'm reading a paper on machine learning. And the next talk about is going to be on AI chips. The reason why you need AI chips is because all the machine learning stuff is based on matrix algebra. Okay, so all during my career, I never used matrices. But today, when I read a paper, wow, I know everything. I understand everything because fortunately, in my later stage in life, I finally made use of the thing that I learned that I never used it during my career. Yeah, let's say nobody knows what happens to you. Okay.
I want to make one more point on that. Is that based on what he was saying too? For you, with AI, people have the power to kind of give AI all and let it produce, but the problem is that they've own that information, so they may not know what that's, they won't be able to do what you're doing. If they let, if we let the AI kind of generate your presentation, do all this stuff, you won't genuinely be able to kind of present those. You need to be able to do it, you need to be able to own it, and that's to some degree what's gonna happen in education. If people are using AI to produce their reports, the teacher can ask them, what did you learn about in this book? And they're not gonna be able to answer, but they never did the work in the first place.
You're absolutely right.
Yeah.
But then on the other hand is that it may not matter, because right now we have AI is what everybody's and learning a little bit more, right? But you don't have to be a PhD in computer science or on AI. Okay, there are people who are going to spend all their 4 or 5 years trying to get a PhD in AI, right? But all of us, we're just users of AI. Just like we all know how to drive a car, but you don't necessarily know how the engine runs inside the car. As a matter of fact, if you know how to fix a car before, now it suddenly becomes an electric car. Now it's different. So even if you know how to tune, I remember when I used to tune the car, I used to take it to a shop and they say, okay, well, it's 8 cylinders or 6 cylinders. And then you have to change the spark plug, so you clean it and you gap it and all that stuff. All of that is gone because all the new cars, they're all microprocessor control. You just pop one chip in there and that's it. So, nobody knows, so everything is continuously changing, evolving. So the right attitude is that keep learning new things and don't get stuck into one thing. Because if you look at the world today, like before last weekend, who knows that besides the Russia, Ukraine, when there's also another thing now coming in the Middle East, nobody can know a priori what's happening. No. So anyway, so again, just to wrap up, since it's already 9 o'clock, I want to thank all the people who came here tonight, and also all the people online who attended the Zoom session. Okay, hopefully you enjoyed it, and if you like it, wait for the next segment. All right. Okay. Bye bye. Huh? Send me an email because it depends on what you're going to use it for. I'll give you my email. Write me an email, okay, and then I can send it to you if you're just interested in having all this stuff. But all of this is all created by me. It's not created by ChatGPT. Huh? Yeah. Why don't you write down my email? Send me an email.